In this video, we're going to establish some formulas to evaluate indefinite integrals that'll make this process a little bit easier. So if you think about when we were first learning derivatives, we started with the power rule. That was our first big derivative rule way back in chapter 2 that we were talking about. And if we think about the power rule for derivatives, there were two steps to that. The first step said we needed to multiply by the power of x, or whatever variable we're taking the derivative of. And then the second step, we would subtract 1 from the power. And we can actually establish a really similar power rule for integrals as well, because if we think about it, when we were looking at the examples before, normally when we're doing a power rule, we're starting with f of x, we use our power rule, we find f prime of x. But when we're working with integrals, we're actually going to start with f prime of x and see if we can work our way backwards to f of x. So I essentially want to take these two steps and see if I can undo them, see if I can go backwards from them. So that means two things. I'm going to have to do the opposite of these two steps, but since the order of these steps mattered, I'm also going to do the opposite steps in the opposite order. So that means I'm going to have to start with undoing step 2. Step 2 said subtract 1 from the power. Well, the opposite of that would be to add 1 to the power. So that would be the opposite of step 2. We look at that instead of subtracting 1 from the power. Well, when we integrate, we're going to add 1 to the power. If we look at the other step we needed to undo, we need to undo this multiplication by the power. Well, the opposite of multiplication is division, so that means that we should instead divide by the new power. And I'm going to make sure I say the new power because we spent so long thinking about the old power with derivatives that we need to maybe kind of just be very specific. We're going to add 1 to the power first and then divide by that new power. The order that we take these steps in matters. So if I wanted to just do a really quick example, let's just do a really quick example. Let's say I wanted to find the indefinite integral of, how about 18x squared dx? Let's suppose that I wanted to integrate this function. I can just use these two steps. So my first step would say add 1 to the power. So I'm going to add 1 to the power of x. So I'm going to keep that 18x. I'm just going to add 1 to the power. 2 plus 1 would give me a new power of 3. And then divide by that new power. So I'm going to divide by 3 because that was my second step. And then, of course, when we're evaluating these, we're actually finding infinitely many antiderivatives. So we need to make sure that we add on that constant of integration plus c. Again, we're going to have to do that every single time. Please don't forget that. And then afterwards, if you can, go ahead and simplify. So for example, I can do 18 divided by 3. That would just be 6x to the third power plus c. Then yes, go ahead and do that. I recommend, and here let me highlight this just so that it's easier to see. I would recommend writing out all of the steps, especially when we're first starting out these. I think it's very, 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 very helpful. It's very easy to make a mistake with these problems. We spent so long thinking about derivatives that now when we move into integrals and antiderivatives, it's very easy to get mixed up. The steps are very similar. It's very easy to mix them up. So I try and show all of the steps, show all of the work, at least when we're starting off. As you become more and more comfortable, if you want to jump to this simplified answer 6x cubed plus c, you absolutely can, but I think it's very helpful to show all of the steps at first because it'll force you to think about, okay, we're adding 1 to the power and then dividing by the power. In general terms, the exponent rule for the power rule would say if we integrate x to the nth power, so we just have x to some power of n dx, we add 1 to the power, so that would be x to the n plus 1, and then we divide by our new power. We divide by n plus 1, and then of course we add our constant of integration c. So that's the first really big derivative rule, probably the one we'll be using most often in this section. There are 2 others that I want to quickly talk about here, and those should be a little bit easier to establish. And I want to think back to earlier derivative rules that we learned at the very beginning of chapter 3, before we even talked about the chain rule and the product rule and the quotient rule. If you think back to earlier sections, we started off by thinking about, say, the derivative of y equals e to the x power. And if I wanted to take the derivative of y equals e to the x power, that means that y prime would have also been e to the x. So we're used to, again, starting with y and finding y prime. So I want to generalize this because I want to be able to integrate. I want to be able to find the integral of e to the x power dx. So that would mean I'm starting with y prime and working my way backwards. Hopefully it's not unsurprising. We can just kind of look at this example and see, well, if we wanted to go backwards, the antiderivative of e to the x would just be itself e to the x. But just like we did with the power rule, we're going to have to add this plus c. So we are still going to need our constant of integration on every single one of these integral rules, on every single one of these antiderivative rules. So there is the second one. The last function that we talked about, remember we talked about y equals natural log of x. The derivative of that function, y prime, derivative of natural log of x, we said was 1 over x. So again, when I think about my antiderivative, I'm starting with y prime, which means I want to know what is the antiderivative of 1 over x dx. Well, if I were to integrate that function, the antiderivative of 1 over x, that would be natural log of x. Now there's one small difference here when we work with natural log, and that's that we should have natural log of absolute value of x. And this is going to just help us with the domain of the natural log function, because the domain of natural log is restricted to only positive numbers, whereas the domain of 1 over x is all non-zero numbers. To be honest, for me personally, I don't care that much about the absolute values. They should be there, yes, but it's not something that I would take points off for on, say, a quiz or an exam. I would probably give you a reminder, and I might, scrunch my face up and make a frowny face, but I don't think it's that big of a deal. Try to remember these if you can, but like I said, if you don't, it's not the end of the world. What is the end of the world, though, is if we forget our constant of integration c. We do still need that in this case. So the antiderivative of natural log of x, the antiderivative of 1 over x is natural log of absolute value of x plus c. So these 3 integral formulas are going to be enough to get us started on a good handful of problems in this section. We're going to be using these 3 rules quite a bit here to practice our integration. These 3 rules are given below, so I would make sure that you have them all copied down, and make sure you get lots of practice in with these, because it looks simple enough and it feels very related to what we know about derivatives, and it is, but again, it's very easy to mix up derivatives and integrals. So we want to make sure that we get that practice in so that we can help change our mindset and shift from always thinking about derivatives to now thinking about this new process of integration.